All right, good morning, everybody. Let's do this. So, graphing trigonometric functions, period. Please have this in your notes, and sorry for my voice. I'm a little sick today. Hopefully it won't change the quality, but the period is the distance between two consecutive maximum points or two consecutive minimum points. So let's take a look at this graph. If we have 2 sine x, we are professionals at this, right? By now, to graph this function, all we need to do is, go up 2, down 2, because this is our amplitude over here, right? This is our amplitude. And we will have a mum-dum, right? So we go middle, and then at pi over 2, it's up. At pi, it's middle. At 3 pi over 2, it's down. And at 2 pi, it's middle. And then what do? We just have our sine curve, and that's it, right? So we're very nice at doing this. Here, we've only learned how to change the height of the sinusoidal function. Here, in this exercise, we're going to show how to change the period. So please have this in your notes, and the formula to calculate the period is equal to 2 pi over b. What this is, we will cover right now. So let's take a look at this function. If we want to graph this function, right, we have 2 sine 2x, right? Before, in all the functions we've just had a number on the outside over here. But now, in this function here, notice we're going to have a 2 over here, and it changes a lot of things. So here, if we look at this, our amplitude is 2, and here, we need to do something with this. Here, we're going to use the formula period is equal to 2 pi over b. This part over here will represent the b, and this will always represent the a, which is our amplitude, right? So let's follow the formula. Our amplitude is 2, right? And according to our formula, period is equal to what? 2 pi over b. So let's use that formula. That period is equal to 2 pi over b, but what's our b equal to here? Our b is equal to 2 as well. So we substitute b into here, and what do we have? We have 2 pi over 2, and 2 pi divided by 2 is just equal to pi. So what on earth does this mean? If you notice here, every cycle of just 2 sine x, it ends at 2 pi. Let's say if we were to use the formula over here, right? What is our b value here? Our b value is equal to 1 in this scenario. So just by the formula, period is equal to 2 pi over b. So 2 pi over b is equal to 2 pi over 1, which equals 2 pi. This 2 pi represents when the cycle ends. Okay? Our sine function ends at 2 pi every time because this is changing our period. But now, what's happening is our cycle is changing, it's ending at pi. It doesn't end at 2 pi. And then what do we do from here? Notice that 2 pi, when I break 2 pi into 4 parts, if we break 2 pi into 4 parts, well, let's see. If I were to break, let's say, 100 into 4 parts, right? 100 divided by 4 is equal to 25. And if I were to break 100 into 4 parts, what would it be? The first part is 25, the second part is 50, and the next part is 75. You have increments of 25. Notice here, when I break the 2 pi into 4 parts, this is equal to pi over 2, right? This pi over 2 is over here. What is pi over 2 plus pi over 2? That equals 2 pi over 2, which equals pi, and this represents this part over here, right? And what if I were to add pi over 2, pi plus pi over 2, then I get 3 pi over 2, which is this part over here. And what's 3 pi over 2 plus pi over 2? Well, that's 2 pi, which is this part over here. So you see, we're constantly adding pi over 2 to every interval because we broke the period into 4 parts. we broke the cycle into 4 parts. And why do we have to break the cycle into 4 parts? Well, remember, if I have our graph, if I have our circle, right? This is, here we go, 1, 2, 3, 4. And then we go around the circle in one shot. So it's always in 4 parts. Here, once our period is pi, what do we want to do? We want to break the period into 4 parts. So if I'm going to break pi into 4 parts, the same way we did it with the 100, right? This is always a nice example. If I say break 100 into 4 parts, well, it's 25, right? And then it's always what? 0 to 100. And the first part is 25, right? And if I want to create 4 equal intervals, right, of 4 equal parts of 100, well, the first part is 25. Then how do you get to the next part? It's 25 plus 25, which is 50. 50 plus 25 is 75. And 75 plus 25 is 100. Okay, so here, notice that we have 4 equal intervals. Well, we're going to do the same thing with pi. So if I break pi into 4 parts, well, then it's equal to what? It's just equal to pi over 4. The same way 100 divided by 4 is 25. Well, pi divided by 4 is pi over 4. So notice that we're going to have it here. This is going to be 0. And the end is going to be pi, because we know the cycle ends at pi. And the same way here, we start at 0 and we know the interval ends at 100. Well, the first part is what? Pi over 4. And then how did we go from 25 to 50? We added 25. Well, how do you go from pi over 4 to the next one? We just add pi over 4, which equals 2 pi over 4. And then what do? We add another pi over 4, which equals 3 pi over 4. And then how do we get to the last part? Well, we just add another pi over 4, and that equals 4 pi over 4. But notice that one thing we need to notice is that here, 2 pi over 4, that's the same as pi over 2, right? And here, pi over 2. And here, notice that 4 pi over 4 is the same as pi. So when we break our interval here, we're going to start at pi at the end, and then the first part will be pi over 4. The next part will be pi over 2. But remember, this pi over 2 is the same thing as the 2 pi over 4. We just simplified it. And then this part is what? 3 pi over 4. Okay, and this is pi. And then notice, this is our interval. Before, our interval ends here at 2 pi. But now our interval is going to end at pi for this cycle. And notice that this is our amplitude, right? So this is 2 and this is -2. And then every sine function needs a what? It needs a mum-dum. So we use mum-dum. And this is it. So we just go middle, up, middle, down, middle. And this is it. Okay? So this is one cycle of 2 sine 2x. And notice here it ends at pi. If I were to draw this graph over here on this graph, notice that here, this is pi, right? Here is pi. So if I were to draw this over here, I would need to, you see here, we have the pi over 2, but we're missing pi over 4 and 3 pi over 4. So we would have to write that over here. This is pi over 4. This is 3 pi over 4. And then it would be what? Middle, up, middle, down, middle. And it would just be just like that. And then this function is here as well, all right? Let's take a look at the next example. Remember, if you're feeling a little confused on this idea of changing the period, just raise your hand and I'll help you with it. Okay, let's look at the next one. We have 2 sine x over 2. Well, let's take a look. What's our amplitude for this function? It's just 2, right? This is the a value. And here, what's the b value? Why don't you take a second and think about it, but our b value will be a half, because 1/2 times x is equal to x over 2. So our b value is 1/2. Now, how do you find the period? Well, let's see. Same thing. What's the formula? 2 pi over b, which is equal to, let's fix the camera angle a little. 2 pi over b, which is equal to 2 pi over 1/2. But then, yeah, so how do we solve this? Before, what was the period? It was pi, because we did 2 pi divided by 2, and the pi's canceled, so we got pi. But how do you evaluate this? Well, you just do your keep, change, flip. So we have 2 pi divided by 1/2, right? But then that's equal to 2 pi times 2 over 1, which equals 4 pi. Okay? So what does this 4 pi represent? It represents when the cycle ends. So here, the cycle ends at 4 pi. Okay? So then how do we break, what did I want to write here? Oh, whoops, sorry. Yeah, break period into 4 parts. Well, here, if we have the same thing we did over there, right? We had pi, right? We took pi and we broke it into 4 equal intervals. We did pi divided by 4. Here, we're going to take this 4 pi and divide it by 4, which just equals pi. So this represents when the cycle will begin. So here we always start at 0, right? And then here, if it ends at 4 pi, remember, let's do the same example always here, that if I say take 100 divided by 4, that's 25. So then we always know that this one is 0, this is 100, and then here we have 25, 50, 75, 100. I always show this example to myself if I ever get confused on how to break the intervals. But the first interval, here we're breaking 4 pi into 4 parts. So this is the first part. And then how do you go from, we start at 25, how do you go to 50? You add 25. Well, here we're just going to add pi. So this is 2 pi. If I add another pi, this is 3 pi. And if I add another pi, I get 4 pi. And then here, we broke it into 4 parts. And why do we always need 4 parts? It has to do with the rotation around the circle. So then here, let's just do it. The top is 2, the bottom is -2 for the amplitude. And now here, we're going to take this interval and just bring it up here. So this is going to be pi, this is going to be 2 pi, this is going to be 3 pi, and this is going to be 4 pi. And what does every sine function need? It needs a mum-dum. Okay? So then let's just follow the rhythm. Middle, up, middle, down, middle. And then, boom, that's it. We have our sine function from 0 to 4 pi. You see, before, our cycle ended, when we had just sine of x, the cycle ends at 2 pi. When we have sine of 2x, the period is pi and it ends at pi. Here, our cycle ends at 4 pi. Okay? Okay. Let's take a second to try and put all of this together so we get a better feel. Here, we graphed 2 sine of x, right? What I want you to do is graph 2 sine of x here. Actually, I'm sorry. Let's graph this one first. The game plan is for you guys to try and put all these graphs together. This graph, and this graph. So what I want you to do is, let's do this one together. It's 2 sine of x over 2, right? This is this graph over here. Let's graph 2 sine x over 2 over here. So then what is it? So this is 2. This is -2. And just so that we're very precise, let me grab a ruler, over here. Let's try and create, you see how we have 0 to 4 pi? Let's make the intervals nice and neat. So let's say if this is 7 inches, divide 7 inches, let's say just like 1.5 inches for each one. This is 3, this is 4.5, okay, this is 6. All right. So here, this is pi, this is 2 pi, this is 3 pi, and this is 4 pi, right? Okay, so we're just going to take this graph and just put it over here. So let's do that. So what do? We need our mum-dum, right? Here we're going to graph this in red. Okay? Sorry. We're going to graph this function in red. So middle, up, middle, down, middle. And then here we go. Okay. Now, we graph this one in red. Now, let's graph 2 sine of x. Remember, from the beginning, 2 sine of x, we know how to graph this one, right? It's pi over 2, pi, 3 pi over 2, 2 pi. But the question is, where does this interval go in this graph? Remember, look, this is the pi, this is the 2 pi, which is right here. But what's the thing that's missing? It's these two guys. It's the ones in the middle, which is the pi over 2 and the 3 pi over 2. So let's put them right over here. So this should be pi over 2, and this should be 3 pi over 2. And then what do we need to do? Let's put this one in, I don't know, let's do it in like an orange or something. So then for this graph, for 2 sine of x, middle, and then remember we go up at pi over 2, down at pi, middle at pi. This is 3 pi over 2 is here, and this is here. And then up, middle, down, middle. Okay? So notice that this 2 sine of x is kind of like, this is the original, right? This is the original. It's like, imagine you take this and you stretch it out. And that's what's happening. You're stretching this out when you have x over 2 here. When we do 2 sine 2x, which was this one over here, notice that our period ends at pi, right? So the pi and the pi over 2 are here. They're right here, right? So the pi over 2 and pi are right here. What's missing? It's these two guys in the middle. It's pi over 4 and 3 pi over 4 because they're to the left of it. So here, this should be pi over 4 over here, and this should be 3 pi over 4. And notice, let's put this in, let's put it in teal or something for this function. And this is middle, up, middle, down, down, middle. And then boom, this is our graph. Notice that we took this one, right? The original 2 sine x. We took this 2 sine 2x, and we took this one here, and we just put them all on the same graph. And notice, remember, the orange represents the original. This 2 sine x over 2, it's pulling it out. And this 2 sine 2x is pushing it in. Okay, so you're changing what we call the period of a function. Okay? Okie dokie. So this was period, and this was the lesson. What I'd like you to do is, let's just think about the lesson summary. If y is equal to a times sine bx, or y is equal to a times cosine bx, the period is equal to 2 pi over b. What I'd like you to do for closing exercise, or if you want to do this for homework, try and graph these two separately. So graph this on one graph this on one graph, and then graph all of them on the same graph from the interval of 0 to 4 pi. Okay, I hope this helped. See you.